Excellent. All right. We are now moving to Jordi Hendricks. Jordi, are you there? My goodness, I just wish you could see how beautiful it is out the window here in Fernie, BC. I just wish so much that everybody was here with us today. But this is absolutely the next best thing. We have Jordi Hendricks with us now. He's coming to us from Montana State University in Bozeman, Montana. Montana State and Bozeman have a long history of avalanche research and alumni that include many respected researchers and practitioners in snow sciences. I've had the pleasure to work with some of them down there in the out of bounds areas of Bridger Bowl, exclusively for research back in the day. We didn't do any skiing though, we just did research. Jordi is the director of the Snow Avalanche Science Laboratory in the university's Earth Sciences Department. A very prestigious and full project, I would assume. Jordi is a researcher as well with the White Heat project that was mentioned earlier. He has spent 20 years working on avalanche projects from the Antarctic to the Arctic and everywhere in between. Jordi's talk today, he will illustrate and provide insight on decision-making in avalanche terrain. Jordi is working with 10 years of data that track users traveling through avalanche terrain in the backcountry. And his team's mission is to extract and distill terrain use and risk information from these users. Jordi, thank you for being with us today. Take it away.
Fantastic. Well, it's a pleasure to be here. Thank you for inviting me to present at the VSSW, and a huge thank you to the organizers for putting on this event. Obviously, with COVID coming in, it's changed the plans, but I think it's been amazing how the organizers have moved with the times and made this possible. It didn't seem like it would be appropriate to not have an ISSW this year, so thank you for letting me be here. So my talk today is looking at how we've used some different techniques to understand how people use terrain. And I want to recognize my co-authors here. This work has been done with a number of other people, including Jerry Johnson, Andrea Manberg, who you've heard from this morning already, John Sykes, Diana Sally, Albert Larson, and Andrew Shower as well. And this work kind of summarizes a number of different projects where we've tried to get at how people use terrain and what that tells us around their decision making and also around their terrain preferences, and how we can use that as a lens to better understand when certain groups or certain people or certain settings might make people make risky decisions than they intend to. So it's trying to tie into some of these ideas that Andrea just spoke about and Laura spoke about as well, but using observed terrain as a lens on that idea. So when we teach avalanche classes, we often talk about how when the snowpack is your problem, terrain is your solution. And the basic idea there is that even under really challenging snowpack conditions, you can minimize or maybe even completely reduce your avalanche risk by using appropriate terrain. Now, at one end of the continuum, we can think about not going into avalanche terrain at all. You know, we can think about abstinence. And we know from other risky decision-making processes that teaching abstinence simply doesn't work. So teaching people how to manage their terrain to reduce their risk is really the way that we want to move forward. And what we're doing is taking what's called a geospatial view on that process. And our idea and the way that we try to frame this is that your track in the backcountry, be that on ski, be that on snowmobile, be that snowshoeing, hiking, heli assisted, be that extreme snow angeling, whatever you want to be doing. But that track is an expression of the sum of all your choices. And the idea behind the work that we've been doing is to say, well, we don't necessarily understand every single one of those choices, but maybe by looking at your track really carefully, we might be able to understand a few of those choices and back calculate based on some other attributes why and who and where and when you made the choices that you did. And sometimes when we look at track data, and here's an example from Wyoming. This is just in Teton National Park. We can see a pretty clear idea about where someone was going. They had a pretty clear objective. We could see where they went up. We could see where they went down. We've also had some survey data that told us who they were with. And we get a pretty clear understanding around the decisions that informed why they went there and where they moved in that terrain. At other times, we're left going around in circles. And this is, if you're seeing it now, it's just pulling up on people's screens, I can see. This is an example of a snowmobile track. So in this particular case, we can see straight away that it's a snowmobile track. Skiers don't tend to leave tracks like this. But again, when we combine that with information on who they are and who they're with, we start getting some ideas around the purpose of the day, and we can extract their risk profile as a function of that. The other thing that we're trying to do is trying to understand terrain use and decision making from the perspective of success. So a lot of previous work has looked at accident analyses, and accidents can tell us a huge amount about what went wrong. But typically accidents are from a series of events. They're not typically just from one poor decision. They're this cascade of situations. We've often seen this analogy of the Swiss cheese, where we have 5 or 6 or 7 slices of cheese with holes. Swiss cheese, traditional Swiss cheese has the holes, or the Emmentaler. And to get a fatal accident, you typically need to have passed through a number of those holes and multiple slices of cheese. So our thinking is that while it's important to look at decision-making or decision-making that led in very negative outcomes, it's also really important to look at good decision-making and see what we can find, how different groups of people make decisions in the backcountry, and how we can tease out the groups that are making better decisions relative to the current conditions, and maybe those that are making risky decisions, and understand why and when those risky decisions are being made. So we're trying to understand the reasons and patterns of risky behavior. And really our ultimate goal in this is to develop targeted education that identifies the groups, the settings, the types of people, the locations, maybe the cultures where we are getting increased risky behavior, so that we can do some type of intervention, do some form of learning, so that we can really try and tackle the number of our avalanche fatalities and prevent people from making poor decisions in the future. This is part of the White Heat Project, this work. Not all of it's been part of the White Heat Project, but it forms part of this wider umbrella where we're trying to understand decision-making and risky behavior in the backcountry. And some of the key questions that we're asking are the who, the when, the where, and the why. So, you know, a lot of this is fairly straightforward, but we've got a lot of unknowns here. So let's have a look at how we can do this. So we've used 4 key different approaches to understand how people use terrain. And each of those methods have got their own pros and cons, and we'll go through what they are. And they provide us with slightly different sets of data. So one of the projects that Robin mentioned right at the beginning was the Ski Tracks project. This is our first attempt that we took at understanding decision-making, real-world decision-making in the backcountry by groups of individuals. This is where we use crowdsourced data. People would submit their data via a smartphone app. First we used a GPS device and then migrated to a smartphone app. And then also send us some information about who they were. We also tried some intercept surveys. This is the work by John Sykes, and I'll talk about that in a second. We've used some passive monitoring using time-lapse cameras. And then finally, we've also been doing some work with Andrea and the White Heat group, looking at hypothetical choice. And that also is a way to look at terrain use through a hypothetical lens, where you can maybe control for some of these other factors and reduce the degrees of freedom that we're trying to deal with in terms of the real world data. So just looking at the ski tracks data, this is just a quick schematic of what's going on with our ski tracks data. I think a lot of people have probably heard me talk about this or have mentioned this project in the past. But the basic idea was that we were asking people when they went out in the backcountry to record where they went using a GPS-enabled device, typically a smartphone. We suggested using the Ski Tracks app because it works, it was pretty good on battery power, and it gave us the sort of data that was easily shared to us. People would send us that data, we would then analyze that data, and we would come up with a series of terrain metrics that we would try and use to enumerate or get an expression of risk from their terrain use. When we received their track, we would also send them a survey. And that survey was really, really important because I think it's really important to look at how people move in the terrain, but you need to put that in the context of who they're with, why they were there, what their motivations are, and bring that together to provide us with a lens or at least some insight into decision making. We published some of this work back in 2016, and a lot of these papers are available to the public as open access. So if people are interested to read more, please take a look at some of these works. But just some themes. We saw that gender was important. We saw that avalanche education was important. And we also saw that group size and group composition was important. And what I mean by group composition is that we saw that people in different types of groups under the same snow and avalanche conditions, i.e. under the same backcountry avalanche advisories, were using the terrain very, very differently. Project that we worked on, and this is John's master's degree, was an intercept survey approach. So the benefit of an intercept survey approach is that
there, just to drop there, Jordy, is there someone in your room?
Nobody in my room. Muted. Thank you. So the other approach we used to look at terrain use was this intercept survey approach. And as I was saying, this was some of John Sykes's master's thesis work. So John, in this particular photo, is standing at the boundary of the Bridger ski area to the backcountry. And he's asking people a few questions about who they are, what they're doing, what their experience is like. And he's asking them to carry a GPS. So those two data sets together provide us with an insight about who you are, where you're going, and some insight into your decision-making processes. And when we go and have a look at his data, and I would encourage you to take a look at his paper if you want to read more, we saw that gender, avalanche education, and people's perception around how that terrain, that backcountry terrain, was controlled. Some people believe because it's adjacent to the ski area that there's still some avalanche mitigation happening, which there isn't. So what we saw is that those three factors were important in determining how people chose terrain, what their terrain preferences were, and how they made decisions. And these are just some summary plots on the right-hand side. These are these heat maps that show basically the density of usage in those areas from John's intercept survey data. The third approach we used, and this was from another project by a master's student, Diana Sally. Diana is an avalanche forecaster with Avalanche Canada these days. And again, take a look at her paper if you want to read more. This was a really innovative project using a time-lapse camera that would take photos every 10 seconds and then basically do a change detection where changes represented movement of people as black dots, these little pixels that were moving from photo to photo to photo. And the shot that you're seeing there in the background is an example from 2016 where we had an avalanche that occurred while the camera was on. And we can see the lines We can see the crown line from the avalanche. We can see the powder cloud just going off a cliff band at the bottom of Saddle Peak. Again, this is adjacent to Bridger Bowl ski area in Montana here. And you can see the different colored dots with the lines. And those lines represent the position change from timestamp 1 to timestamp 2. And using over 31,000 images, she managed to understand and look at how different backcountry avalanche advisories influence the point density of where skiers were. So she used over 32,000 images, 7,499 skier data points, and compared those to different avalanche advisories. So again, we can see that people's terrain, in this case, is changing as a function of the backcountry avalanche advisory. So for those of you that are forecasters out there, those of you that are producing backcountry avalanche advisories, this, I think, is a very positive outcome. We would like to think that people modify their behavior as a function of the avalanche advisory, and certainly in this case study, they did. The final area that we've been looking into are these hypothetical choices. And this is some of the work we've been doing under the White Heat Project with Andrea Manberg, Marcus Landro, and also Martin Stefan, looking at how we might choose that, how we might prefer or accept different choices around terrain in a hypothetical case when we have a given snow and avalanche conditions. And what we see in this work is that our attitudes and perceptions predict our hypothetical choices in terms of what we would prefer to ski under the given scenario. But also really interestingly, and Andrea has already mentioned this, is that, you know, maybe what we accept to ski is different to what we would prefer to ski. So the role and the influence of the peer group, the people we're with, and what decisions are happening around us. So this gives us some more insight into why we make decisions that we do and what that results in terms of the terrain. So it's kind of looking the other way at how we use terrain. So if I think about those 4 different approaches, and we think about how we use terrain and how we make decisions there, we can look at the why, we can look at the where, we can look at the number of people we sample, and we can start looking at how this all comes together. So for our crowdsourced ski tracks data, we have pretty good data on where people were. We collected a good number of tracks. We had over 4,000 tracks. Not all of those were usable to us because we didn't have all of the survey data to us. We have some idea about who those people are. We don't have an amazing understanding of the why. The why still, by and large, eludes us because we don't have a microchip inside everybody's head. We can't understand every single piece of decision making. We're really just inferring key decisions from the terrain that you're using. We look at the Intercept Survey approach. We get a pretty good understanding about where. We get a pretty good understanding about the why. But our numbers are limited. And our scope of inference is also limited because, unfortunately, we don't have unlimited resources. We can't put thousands of people out at every trailhead doing these types of intercept surveys. So we get a biased survey as a function of where we're standing and the cohort, the culture of the groups that are in that area. We think about our time-lapse approach. I think this is a really exciting way to passively document where people and how people are moving in terrain. I also think it has some real benefits in terms of operational safety. And in fact, one of the things, the partnerships that we've developed here in Montana is having Bridger Bowl use that to, in the case of an avalanche in the backcountry there, to look at the data, to go back in those images and use it to help guide a rescue scenario so you can see the number of people that were maybe involved in an avalanche. So it also has a tracking capacity as well as maybe an emergency response and rescue capacity. And then in terms of our hypothetical choices, again, because we use a survey approach, we can get pretty far into the numbers. We can get a lot of people to engage in this process. We can get a pretty good understanding about the why. And we also have a pretty good understanding about the who, but we don't really have a good understanding about the where because it is hypothetical choice. And it's really a measure of how we're looking at our risk preferences. Some general themes from all of this is that gender, avalanche education, perception of mitigation, regional danger, and group factors are important about how we make decisions and how we move in our terrain. However, I think the piece that we need to really stop and think about is that terrain is not exactly equal to risk. Avalanche risk is the probability of harm from an interaction between people, avalanche hazard, and specific elements at risk. Avalanche risk is determined by the exposure of those elements, vulnerability to the avalanche hazard. And that's something that Grant wrote in an ISSW paper a number of years ago. And you've probably seen this figure here, where avalanche hazard and vulnerability and exposure equals our avalanche risk. We can obtain the avalanche hazard, or at least at a regional scale, from the avalanche advisories where they're present. And most of our data is from areas where we have avalanche advisories. And really what we're trying to measure is this exposure component. So what does someone's exposure look like? And how does that exposure change as a function of who they're with, where they're going, and what the conditions are? And that then gives us a sense about that avalanche risk. So a key component to that is using it in terms of backcountry avalanche terrain. So one way we can go about doing that is connecting it to terrain and risk. And borrowing from the Canadian Avalanche Association, this is a table in the technical aspects of snow avalanche risk mitigation. It's a fantastic resource that I encourage you all to take a look at. There's this ATES, which is the Avalanche Terrain Exposure Scale Experience Risk Matrix. It's used for operational professional use. And this basically shows that as we head towards that bottom right-hand corner, we have increasing risk. So by combining an assessment of terrain with the local avalanche forecast, with someone's skill set, we can start getting at what people's risk actually looks like. So using a very similar framework, we could use our tracks, and we've compared this with our tracks on some ATES mapping to what people's skill sets are, to understand what their objective risk is versus what their subjective risk is, which is what their assessments were of the risk on that given day. And it's a broad brush approach, but it does allow us to start seeing the types of groups, the types of settings where we have increased risk from certain types of groups moving in the back. The challenge with that is that ATES is not mapped everywhere. However, this is also an area that we're working towards. This screenshot here is from a new product that was recently released in Norway. It shows it's a modified ATES called the CAST mapping. This was led by NVE, the National Avalanche Forecasting Service in Norway, and Halvard Larsen, who led this project. And what you can see here is kind of a broad scale ATES map for a section of Norway. They have this now for all of Norway. And you also have a route there that's shown that has a ATES classification for the route. And this is done for planning purposes, so you can get a sense of the seriousness of the terrain that you're heading into. So we now also have a beta version of this running for most forecast regions in North America. And using the combination of wide-scale terrain mapping with these various ways of measuring terrain, we're starting to understand how and where people move in the backcountry and what their relative risk profiles are. There's some ongoing development in this area that we're really excited about, and I would encourage you to take a look at the poster session. There's a poster there called Development of an Automated Avalanche Terrain Exposure Scale Maps, Current and Future. Please go and have a look at all the posters, but especially take a look at that if you're interested in ATES and where we're moving to in that. But I'm really excited about using this as a framework to understand how our terrain and what our resulting risk profiles are by our real world terrain usage. And then there's also been some development, and Grant Statham, I've seen him in the attendees here, I can speak to this, there's also been some development of updating and going towards an 8th version 2 that redefines some of those categories of the exposure of the avalanche terrain exposure scale and how that changes in the terrain. So just looking at our key elements of the data that we have so far, we have observed terrain use. So if we think about our avalanche triangle, that tells us something about how people move in that terrain. It also tells us a bit about the weather. Certain types of terrain are more favorable under certain weather conditions. We obviously don't want to be using ridge terrain if it's blowing at 100 kilometers per hour. So looking at terrain use by groups tells us a bit about what conditions they're under as well. Also tells us a little bit about the snowpack. We also get snowpack information when we look at the regional avalanche advisories. So we can pull that information together as well. We also get some information about groups and individuals. People do surveys as part of most of our terrain use data collection. And that gives us information about our human factors. And our hypothetical choices also informs us around human factors. And that's obviously the central part of our snow, weather, terrain, avalanche triangle. And our AITS mapping is critically important there to try and provide a quantification of our risk. So, what are we moving towards in the future? Well,
you're moving towards a conclusion, I hope, because you're running out of time. You ready?
I am indeed. We are looking at combining our real-world tracks with our hypothetical choices by overlaying what people said they would do within some of our surveys and how that looks in terms of our avalanche terrain. So we can look at what someone said in a hypothetical choice. This is what they actually did in the backcountry setting. And that really allows us, I believe, to understand the who, where, and why of decision-making in avalanche terrain. So I just want to leave everybody with something to think about. The next time you're standing up on a mountain slope, thinking about where you might go, think about how your group, how your setting, how your location influences the choices you make and the terrain that you use. And what would your track say about your decision making? What would it say about the influence of your group? And what would it say about your risk tolerance? And the next time you go out into the backcountry as a professional or as a recreationalist, think about the line you leave on the snow and in the mountains and what that says about your objective and your subjective risk and whether that could be a better line if you were to do it again in the future, and how we can use our lines and our track to influence culture, to make good decisions, to be safe in the mountains, and to all come home safely. Thank you very much.
Thank you, Jordi. Very interesting topic and very important to this community. And I think that all dovetails really well with the previous talks and how do we improve people's decision-making in the terrain, which is the most important part of avalanche safety. Okay, we have time for one question. Do we have any questions? Okay, so any mail-in questions or text questions? Okay, unfortunately, you burned up all your time there, Jordi, but it was very interesting. And we just want to thank you from all of us here in Fernie for participating in the virtual snow science workshop and your contribution to this event and to avalanche research and education in general. Thank you, Jordi.
Thanks for having me on. Have a great morning.